Bismillahirrahmanirrahim. Welcome to Chemistry for class 9th. Lesson for week 4 starting from 27th April to 1st May 2020. Assalamu alaikum. Hope so everybody is safe and healthy at home and are following the lessons regularly and are also completing your written assignments and are grading them as well. In this week 4, we'll continue with chapter number 4, that is structure of molecules, and we'll continue with part 2 of this chapter. As in part 1 of this chapter, as a part of previous lesson, we completed chemical bonds and types and its types. Now we'll continue with the intermolecular forces and its types in this part. Let's talk about the subtopics we are going to cover in this lesson. The subtopics we are going to cover are intermolecular forces, polar and nonpolar covalent bonds, dipole-dipole interactions and hydrogen bonds, glues and adhesives as also part of application of intermolecular forces, and properties of ionic and covalent compounds. The lesson objectives for week 4 are to define intermolecular forces, to differentiate between polar and nonpolar covalent bonds, to differentiate between dipole-dipole interactions and hydrogen bonds, to state uses of glues and adhesives in our daily life, to predict properties of compounds based upon nature of bonding, and to practice paper solving skills. Here I have also listed some additional resources for each subtopic. You people may find it in as a part of resource file as well, and you can click on each of them to extend your respective understanding. Okay, let's start with intermolecular forces. Intermolecular forces are the forces of attraction that holds the two atoms together. If you recall the definition of a chemical bond, that stated that the attractive forces that holds two atoms together, they are called as chemical bonds, and we may also call them as intramolecular forces because they are holding two atoms together. But now we are going to talk about the attractive forces which are holding two molecules together, so they are called as intermolecular forces of attraction. Here the intermolecular forces of attraction have been illustrated in front of you with the help of by showing you two molecules of HCl, and in these two molecules of HCl you people are shown with let me show you the chemical bonds which are holding these two the two atoms in each molecule together. HCl are held together by chemical bonds. These are the two different molecules of HCl, whereas between these two molecules there are certain forces of attraction which are holding them together. They are called as intermolecular forces of attraction. They are indicated by dotted line, as you can see them closely. Intermolecular forces are always weaker than intramolecular forces. It means that we cannot compare the strength of intermolecular forces with that of the strength of intramolecular forces or chemical bonds. Chemical bonds are much stronger as compared to simple intermolecular forces, because chemical bonds are formed by involvement of electrons either in the form of loss or gain of electrons or sharing, or either sharing. Whereas in intermolecular forces there is none such involvement is there. It's just the attractive forces which are pulling the two molecules together. They are weaker as compared to chemical bonds. So please, if an MCQ or a question asks you about comparison of any of the covalent bond with that of any of the intermolecular forces, either it is dipole-dipole interaction or either it is hydrogen bond, do not get confused. Chemical bonds are always much stronger as compared to any of the intermolecular force. So intermolecular forces, the let's move to, after this let's move to the simple illustration that is shown in front of you with the help of two different molecules, HCl and water molecule. Let's first talk about HCl. You can see a Cl partial negative, getting partial negative because it is electronegative as compared to hydrogen. Hydrogen is electropositive in nature, and both of them are held together by this chemical bond. Similarly, you can see another HCl which is also held, the two atoms are held by chemical bond, whereas the two molecules of HCl, they are held together by intermolecular forces, that is by indicated as dotted line between them two. I have outlined it with a rectangular shape. Similarly, you can see I am pointing all the covalent bonds of water with arrows, whereas you can see the intermolecular forces are shown with the help of this dotted line, and this intermolecular force is weaker as compared to chemical bond or intramolecular force. One thing more I would like to mention over here is that HCl example is given to you people as an example of one of the intermolecular force, dipole-dipole interaction, and remember water as an example of the other intermolecular force, that is hydrogen bonding. We'll discuss both the types later on in coming slides, but over here I just want you to keep this point in mind, that we have both these examples as a part of two different types of intermolecular forces. One is dipole-dipole interaction and the other is hydrogen bonding. Okay, let's talk about difference between polar and non-polar covalent bonds. We also discussed a small part of polar and non-polar covalent bonds in previous lesson of week 3 as well, just to give you an initial idea of that. Now we'll talk further in detail about these types of covalent bonds. Non-polar covalent bond is the bond which is formed between similar atoms and with no electronegativity difference. I repeat, non-polar covalent bond is formed between two similar atoms with no electronegativity difference between them. For example, Cl2 molecule is formed, two chlorine atoms joined together and they share the last electron and complete their octet. But as the bond is formed between two similar atoms and the electronegativity difference is 0, so the shared pair of electron is held equally between the two chlorine atoms. Therefore, there is no charge distribution in such molecules, no poles are formed. These molecules are called as non-polar molecules. Whereas on the other hand, if a covalent bond is formed between two different atoms with some electronegativity difference, then in such a case the one which is more electronegative will become partial negative, whereas the one which is less electronegative will become partial positive. And such a case is said to be formation of partial negative and partial positive is said to be forming a dipole, and because two poles have been generated, and as a result dipole, such molecule is called dipole. Two poles are there, and as a result of this dipole, the interactions which will develop between such molecules, they are called as dipole dipole interactions. And in these molecules, in polar molecules, the shared pair is not held equally, and the one which is more electronegative will share the electron more towards itself. Okay, let's move to the next: polar covalent compounds and non-polar covalent compounds. In polar covalent compounds, there are comparatively stronger forces than van der Waals. Van der Waals are the weakest intermolecular forces which exist in non-polar molecules. Whereas in polar molecules, we have poles developed, and as a result of these poles, we have they are called as dipoles, and dipole interactions are much stronger as compared to van der Waals. So they have a stronger forces of attraction in polar covalent molecules as compared to non-polar. Similarly, when we dissolve polar covalent compounds, they dissociate to give ions in water because they have partial positive and partial negative terminals. So they produce ions, and as a result they conduct electricity, and they have high melting and boiling points. Whereas on the other hand, the non-polar covalent compounds, they do not dissociate and to form ions, and they have comparatively low melting and boiling points, and they do not conduct electricity. This is a comparison between polar and non-polar covalent compounds. Okay, let's move